In this video, we have two integrals to evaluate, both involving the exponential e. Now, if you're not sure what method to apply, sometimes it's easier to look for a formula. So here, the first one we have e, square root of e to the x. And I know that if I have the integral of e to the x, let me just call it u, e to the u du, that's e to the u, plus a constant of integration. Now, if you have a constant here, some number k, you can just factor that out. And that'll just multiply what we got here. So what I'm going to do here is I'm going to rewrite this as the integral of, now I can write this as e to the x over 2. Because this is just saying the square root of e to the x. So it's a power of this expression here. So the 1/2 multiplies the x, I get this. And then what I do is I put the 4 out in front, take it outside the integral, like that. Take this to the numerator. It changes the sign of the exponent, so this becomes e to the minus x over 2 dx. So this is what I have when I rewrite it. Now if I could make this a u, it would be just like the formula I just set up here. So let's let u equal to, and you don't have to do this, but if it makes it easier for you, then go ahead and do it. Let u equal to minus x over 2. Then du, derivative of minus x over 2, that's minus 1/2. Then you have the dx. So now I have to convert this integral here to one involving the variable u. So I'm going to multiply by a -2, and I put -2 du over here, and that'll leave me with dx on this side. So now the dx can be replaced by -2 du. Got a 4 here. Dx is replaced by -2. I put the -2 out in front, and then I've got the e. And the exponent minus x over 2, that's your u. So this is to the u power. And then I got the dx here. Or I should say du. So again, make a substitution. And then the dx right here get replaced by -2 du. There's -2. And the du is over here. Then I can factor this out. It's constant, so that the -2 comes out and multiplies the 4. And this gives me a -8. And of course, e to the u, just replace the u by the substitution. So I get -8 e to the -x over 2. And I have the constant of integration. So being familiar with the formula for the integral of e to the u du allows me to rewrite this in terms of u, and I get this answer right here. -8 e to the power of -x over 2 plus a constant. Now the second one, it's not as clear here, and sometimes you have to experiment a little bit. You might want to let u equal to e to the x plus 3. You might let it equal to e to the x minus 1, and then play around with it until you can get it in a form that you can integrate. So this is what I did. And again, I want to say there's more than one way to work these problems out. I let u equal, I couldn't let it equal to e to the x minus 1, but I thought it might work out easier if I let u equal to the square root of e to the x minus 1. And then to get rid of this radical, I'll square both sides. So this gives me u squared, square the right side, and get e to the x minus 1. And then I take the derivative. So the derivative of u squared with respect to u gives me 2u du equal to derivative of e to the x minus 1. Derivative of -1 is 0, so this is just going to give me e to the x, and this will be dx. So my objective then now is to try to convert this integral into one that involves the variable u, and at the same time makes it easier to integrate. So what do I have here? For the, notice here for the e to the x, there's an e to the x, I can put that together with the dx, so it's e to the x dx right here. That can be replaced by 2u du. Remember this right here, the square root of e to the x minus 1, that's going to be the u. I don't have anything for e to the x plus 1. I can't leave the e to the x here. So what I do is, for right here, this implies, if I add 4 to both sides here, this will be u squared plus 4. And if I add 4 to the other side, 4 and minus 1 is 3, so this is going to equal 2 e to the x plus 3. Now I can rewrite this. So this is going to equal to the integral. Okay, this right here, square root of e to the x minus 1, that's u. So this will be u right here. Remember I said the e to the x dx. That'll be 2u du. 2u du. I'll put the 2 here, then a u here, and then a du over here. And then for the e to the x plus 3, that's e squared plus 4. U squared plus 4, I should say. And we have the integral. Let's just multiply this out. 2 and then u times u. So this will be a 2 u squared du over u squared. Now this has to look at partial fractions because you have a rational expression here for the integrand, but it's not in simplest form, so I'd have to reduce it here. So what I'm going to do here is I'm going to divide the numerator by the denominator. So I have a 2u squared divided by u squared plus 4. U squared to 2u squared, this will be a 2 here, long division, and 2 times u squared is 2 u squared. 2 times 4 is 8, plus 8 here. Then we subtract. This cancels out, 2u squared minus 2u squared, and then 0 minus 8 is a minus 8. So this can be written, this integrand can be written as 2 plus, this is the remainder, this is the divisor here, so this would be written as minus 8 over u squared plus 4. Now we're ready to integrate with respect to u. I could break this up into 2 integrals here, but I just do it term by term, and I'm just going to say the integral of 2 with respect to u is 2u. Now this one, I'm going to write it this way. Before I integrate, I'm going to say this is the same thing as factor out the minus 8, and then it'll be the integral of 1 du, or just du, over u squared plus 4. And this formula for this type of integral here, I derived in an earlier video, and then I used that formula to integrate a second problem that was given. So on this one here then, I just have to go back, integrate and go back to the original variable. So here I have a 2u, but what is u? U is that. So that's part of the answer. I'm going to go back to the original variable. So this is going to be the square root of e to the x minus 1. And then it's minus 8. This is the formula that we used. This generates the tangent inverse function. So I'm just going to put tangent inverse of u. Again, in our case, u is the square root of e to the x minus 1. And that's over a. A in our case is 2. That would be 2 squared is 4. So this would be a 2 right here. And by the formula, the coefficient of that tangent also gets divided by 2, whatever a is. And let me write the formula here. The integral of du, or 1 du, over u squared plus a squared, where u is a function of x. The integral of this is always going to be arctangent, or tangent inverse, of u over a, plus the constant of integration. Now if you have a number here, or a constant here, that just multiplies. I say this is k, well this would just be k times that. So that's pretty much it here. So let's just put the final answer over here then. Pretty much have it there. This will be a 2 square root of e to the x minus 1. And then over here, this is minus 8 over 2. So let's reduce that to minus 4. And that's times tangent inverse of the square root of e to the x minus 1. And that's over the a, which in our case is 2. And plus the constant of integration. So the final answer right here. Again, 2 square root of e to the x minus 1 minus 4, tangent inverse of the square root of e to the x minus 1 over 2, plus the constant of integration. Thanks for watching. We'll see you next time.